Hello friends, welcome to my channel. Let's have a look at problem 263, ugly number. So in this video, we're going to share a solution based on integer division. However, our purpose for this video is not to solve this specific problem, but we want to emphasize several extensions. First, let's look at the problem statement. So an ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return true if n is an ugly number or not. So here are several examples. So in example 1, so 6 equals 2 times 3, so it is an ugly number. So for n equals 1, so this is not, right? Because 1 is less than 2, right? So it has no prime factors. Therefore, all of its prime factors are limited to 2, 3, and 5. So in this sense, so this output is true. So we will make this more rigorous, right? So in example 3, so when n equals 14, so 14 equals 2 times 7. So 2 times 7 is actually its integer prime decomposition, so it's not a ugly number. So here the constraint says that n is a 32-bit integer. So with that said, so we are ready to look at the method. So also we need to make an adjustment according to example 2. If for n equals 1, it returns true. So here, so our method or our thought is integer division. So here the observation or a mathematical definition of an ugly number in the current context is the following. N is an ugly number in the sense of the current problem if and only if n equals the product of some certain powers of 2, 3, and 5. So here the exponent m, k, and l are non-negative integers. So here I wrote that for some non-negative integers m, k, l, such that m plus k plus l is greater than 0. So here m plus k plus l greater than 0 is meant to see that not all of them are 0. So, but in view of example 2, actually we can relax this to be m plus k plus l greater than or equal to 0. So this is just a convention. So another thing to notice is that, so because here we write n into such form, so n is non-negative, right? Because the exponentials of 2, 3, and 5 are non-negative. So which basically said that deals with this part, positive. So an ugly number is a positive integer. So here the idea is very simple. So we could reduce n to be 1, right? So here let's say 2 by doing integer division with the divisors 2 and 3 and 5. So we are going to write a solution based on this idea. So this is actually very simple to implement. So here, before we write the code, so here are several extensions or related Leetcode problem you can find, or you can just solve directly. So the 3 extensions are the following. First, a judgment of a prime number. So how to judge if a number n is a prime number. So this can be a interesting problem to try. And the second one is the prime decomposition. So given a positive integer, so let's fix the integer to be positive. How to do prime decomposition? In other words, we write n into the product of prime factors and their powers, like p1 to the power s1 times p2 to the power s2, and so on. So this is the second extension. The third extension is the following. So the count primes. So given an integer n, which is no less than 2, so find the number of prime numbers in the interval. Left side is open and the right side is closed. In other words, greater than 1 and less than or equal to m, right? So it's actually helpful to think these problems and do some practices. So now with that done, so let's do the coding here. So this is actually very simple, right? So first, because of the problem statement, an ugly number is a positive integer. So first we want to check this case. If n is less than or equal to 0, so a non-positive, right? So we are going to return false. So this is actually very simple. So next we want to eliminate or reduce according to the factors 2, 3, and 5. For this, I'm going to write a hyperfunction. So I'm going to call it f. So here n is the target. This number we want to reduce by the prime factors 2, 3, and 5. So m is another number. I will call it divisor. So we want to eliminate the m factors from n. So this is actually very simple to do. So we can introduce a temporary variable just for convenience, s equals m. Then what we're going to do is that, well, s modulo m equals 0. So thus we have factor m inside s. So we're going to do integer division using m. So we update s by this, right? And then we are going to return as the final state of s after the while loop. So the effect is that, so after this while loop, so we return s. S has a state that such that s contains no m factors. So this is the problem statement. Then for this problem, we can set s to be n, right? And then the prime factors, let's see, we are going to reduce using 2, 3, and 5. So for m in 2, 3, and 5, so I'm going to use a list. You can use a set. So then we are going to do this. We call this hyperfunction for s. So notice that s is updated in the for loop, right? So for m. So well, if we can eliminate all 2, 3, 5 factors inside this n. So if n is an ugly number, so the final state should be 1, right? So we're going to return whether s equals 1, right? So if s were 1, it means n at the very beginning is an ugly number, otherwise not. So with that said, so we finished the coding part. Now let's do a check. Yeah, it passes the first example, right? So now let's check one more thing for the first example. So for the first example, so we actually can check 1, right? So yeah, it passes this special case. So now let's do the test for the generic case. Yeah, it passes all the generic cases. So I guess for this problem, so this is one format of solution. So to be frank, for this problem, the coding part is not what we want to emphasize most. So here we actually emphasize the extensions. So actually, it's good practice to try to solve these 3 problems. So with that said, I guess that's about it for this video. Thank you.